All right, so example 13, this is the last example on the graphs. And example 13 says the temperature K of a liquid T minutes after heating is given in the table below. All right, I think K, we could probably say K is in degrees Celsius. K is in degrees Celsius. The temperature K in degrees Celsius of a liquid, T minutes, or K could be Kelvin, whatever. T minutes after heating is given by the table below. All right, so we have the time and we have the temperature. So at the time T is equal to 0, that's when the heat source is removed, and this substance is allowed to cool. And as the substance cools over a 60-minute period, the temperature is recorded. So immediately after the heat source was removed, the temperature was 96 degrees Celsius, and after 60 minutes, the temperature dropped to 25 degrees Celsius. Using a scale of 2 centimeters represent 10 minutes on the horizontal axis, so time is on the horizontal axis, and 2 centimeters represent 10 degrees on the vertical axis. We're to draw a graph of the liquid cooling. All right, so let's draw our graph. The points we're plotting are 0, 96, 10, 64. So we're plotting 0, 96, 10, 64, 20, 44, 30, 33, 20, 44, 30, 33. I think 40 was 28, 50 is 26, and 60 is 25. These are the points we're plotting. The first thing I observe is that there are no negative values. So if there are no negative values, I could probably draw a pair of X L axes. So I'm drawing my vertical axis here. And I'm doing this like this because I do not have any negative values. And I probably draw my horizontal axis, let us see here. Now on the horizontal, we have temperature, not temperature, time in minutes. So we have 0, 10, 20, 30, 40, 50, 60. 10, 20, so it's 2 centimeters to 20 to 10 on both axes, 10, 20, 30, 40, 50, 60, 90, 100. All right, our first point is 0, 96. On the y-axis, stuff is going up by 1. So if this is 90, 91, 92, 93, 94, 95, this would be 96. So 0, 96 should be here. 10 would be 64, 10, 64. So we have 10, 10, 60, 1, 2, 3, 4. 10, 64 is here. Then 30, 30, 30. Sorry, 20, 40. All right, is it 20, 40? Go back and check. It's 20, 44, not 20, 40. 20, 44. So 20, 44 would be here. 30, 33, 1, 2, 3 would be here. 40, 28, 25, 26, 27, 28 is here. 50, 26 is here. And 60, 25 is here. So we can see that the temperature is falling over time. It's a curve, so we have to draw this by a freehand. All right. Relatively easy to do when you practice it a lot. All right, so that's my curve. My curve will look something like that. All right, so this is my coding curve. Let's answer our questions. The questions we're asked is, it says, use your graph to estimate the temperature of the liquid after 15 minutes. So what we're going to do is identify 15 minutes at the bottom. All right, give me a second for the thing to just settle. So 15 minutes at the bottom. We have 10, we have 20. 15 is between 10 and 20. So everywhere along this line, the temperature is, that's 15 minutes. Wherever I cut the curve, I'm going to draw a horizontal line. Cuts the curve here, I draw my horizontal line. All right, but if I want to be 100% specific, all right, so we have 50, this is 51, and this is 52. So that looks like 51.5. So to answer the question, when the time is 15 minutes, the temperature, or after 15 minutes, the temperature fell to 1.5 degrees. So to answer this question, I would say when T is equal to 15 minutes, 15 minutes, the temperature K is equal to 51.5 degrees. Your answer might not be exactly like mine, but it should be relatively close to mine. So after 15 minutes, the temperature fell to 51.5 degrees. II is asking for an estimate of the rate of cooling of the liquid at T is equal to 30 minutes. Guys, when you're doing graphs and you ask for rate, most times that is referring to gradient. So what we need now is the gradient of the curve at the point at T is equal to 30 minutes. So we're going to now go back to our curve and determine the point on the curve where T is equal to 30 minutes. So I'm drawing my line up. This is T is equal to 30 minutes. So this is the line, T is equal to 30. It cuts the graph here. Let's change our color ink. So this is the point on the graph where T is 30 minutes. So because it's gradient and it's gradient of a curve, I told you that to find the gradient of the curve, you've got to draw the tangent, because what we're really doing is to find the gradient of the tangent, which is equal to the gradient of the curve. So at this point, I'm going to try and draw my tangent. Remember, the tangent is a straight line that touches the curve at this single point. Now, it's very easy. What I just did, you must not do. Because you notice that mine will sort of snap back in place. Yours probably won't do that. All right, so you want to draw a line that just touches the curve. And I've roughly, so that's probably a good approximation. Well, it could be tilted a little bit more down. All right, want a line that just touches the curve. All right, now what you have to do is that you have to maneuver your ruler until you get an approximate line like this. Don't draw it until you are 100% sure that, yeah, this looks like roughly it. Now, after you do that, you need 2 points on the tangent. You can find 2 points easily. Here's one. You can easily identify that this is the point 1045. 1045, that is the point. And this is the point here. It's called the point of contact. That is the point 30, 33. So those are 2 points on the tangent, 1045 and 30, 33. So going back up. So my gradient M, which is y2 minus y1 over x2 minus x1, my 2 points, 10, 45, and 30, 33. Those are 2 points on the tangent. So I'm calculating the gradient of the tangent. This is x1, y1, x2, y2, m is equal to y2, which is 33, minus y1, which is 45, over x2, which is 30, minus x1, which is 10. So what I have here is, this looks like 12, minus 12. Yeah, it looks like minus 12 over 20. Now, minus 12 over 20 is the same as saying minus 6 over 10. And minus 6 over 10, for me, M, my gradient, is minus 0.6. And the unit for this gradient, the vertical is, which is the top, is degrees Celsius, and the horizontal is minutes, so it's per minute. The gradient, or the rate of cooling at T is equal to 30 minutes is 0.6 degrees Celsius per minute. That's how fast the thing is cooling at T is equal to what? 30 minutes. Please note, the negative there is showing that the temperature is going down. That's what the negative is doing. It's showing that the temperature is going down. The negative is showing that the thing is sloping down, indicating that the temperature is falling. So the rate of cooling is actually 0.6. And the negative there is just showing that it is going down. It is cooling. That's why it's called the rate of cooling. And the rate of cooling is 0.6 degrees Celsius per